You've done it. You made it here to the end of the Python tutorial. And truly, I really think you should feel good about that for a lot of reasons. Whatever reason you're studying programming, it doesn't have to be commodified and sold for it to be worth learning. And you don't have to become a master of it or anything particularly special to make it worthwhile to spend your time trying to expand your mind and expand your horizons. So you should feel good about it. This one's particularly kind of dense and oddly specific. It's about it introduces various tools that are unlikely to be things that you'll need to be using on a daily basis anytime soon. Kind of bridges that you can worry about crossing when you get to them. So I'm not going to try and explain each one too much. Part of that is also because some of these are still a little confusing to me. I'm just going to introduce them, read the example code and read it, and then you'll be done. A brief tour of the standard library. Operating system interface. The OS module provides dozens of functions for interacting with the operating system. You can, once you've imported it, use things like .getCwd to return the current working directory. You can use .chdir to change the working directory. You can use .system to run the command mkdir in the system shell, which would get 0 at this point. Be sure to use the import OS, say just import OS, rather than from import or from OS import everything indicated by a star, because this will keep os.open from shadowing the built-in open function, which operates very differently. Now, the built-in directory and help functions are useful as interactive aids for working with large modules like OS. If you want to just see what all module functions in it, or any other module, you can say dir and then pass in the module, after it's been imported, of course. And help OS, in this case, would return an extensive manual page created from the module's docstrings, which is also a hint as to why writing your own docstrings could be important in the future, because that's how people will figure out what the fuck it does. For daily file and directory management tasks, the shuttle, which is a shell utility module, or shell utilities module, provides a higher level interface that is easier to use. Speak for yourself. So in this case, import shuttle, we can use the .copyFile method to copy some file to another, I guess, because we get archive.database after both of these are passed in. Shuttle.move, move stuff to a different directory, I'm assuming. File wildcards. The concept of this was I was going to read it. I'm not necessarily explain every bit. The glob module provides a function for making file lists from directory wildcard searches. And glob is global. Import glob, glob.glob, with the string star.py passed in, would unpack it and make a list out of all the .pys. Command line arguments. Common utility scripts often need to process command line arguments. These arguments are stored in the sys module's argv attribute as a list. For instance, let's take the following demo.py file. We can import sys and print the .argv of sys, and here's what would be the output from running python demo.py 1, 2, 3 at the command line. We'll make a string separating each of these things that are separated by spaces at the command line, make them into a series of strings in a list. The argparse module provides a more sophisticated mechanism to process command line arguments. The following script extracts one or more file names and an optional number of lines to be displayed. After it's been imported, you can set the value of a given variable equal to the result of using argparse.argumentParser, in which you can make these specific, these more, a more sophisticated mechanism. You can set prog equal the program equal to top, the description, show top lines from each file. Then parser.add argument, you can add more arguments to be, or more, I mean, you're adding parameters, right? I mean, that will be passed in as additional arguments later. File names, nargs. And you can, here you add an argument, -1, and like dash lines, a type keyword argument, another keyword argument. And then when run at the command line with python top.py, and then see, you would be passing in arguments at the command line that you define the parameters for using parser.add argument. So you would have to say how many lines, etc. Now, the script would then set args.lines to 5 and args.filenames to a list containing the strings alpha.txt and beta.txt. Error output, redirection, and program termination. The sys module also has attributes for standard input, standard output, and standard error. The latter is useful for emitting warnings and error messages to make them visible even when standard output has been redirected. So, say sys.standard error, stderr, .write. Here's your custom message, warning log file not found, starting a new one, new line character, and that's what you get. The most direct way to terminate a script is a gun. No, it's to use sys.exit. String pattern matching. The re module, RE, which stands for regular expressions, the re module provides regular expression tools for advanced string processing. And if you don't know what regular expressions or regexes are yet, it's worth looking into, but don't worry about like memorizing them all yet. I mean, because you can always just look them up. But for complex matching and manipulation, regular expressions offer succinct, optimized solutions. So for instance, after we've imported the re module, we can re.findAll, and then we pass in these, this is regular expression. These fancy, weird symbols all define like a very advanced search function. And it will help you find specifically things that meet criteria that are, in a symbolic way that you can't tell by looking at it, are defined here. And this would return foot, fell, fastest. And I'm pretty sure, I mean, like it's got to have F as the first letter. I haven't memorized all the regexes, so I'm not sure what this means specifically, but re.sub, and with these regexes passed in, we'll take cat in the hat out of the string cat in the hat. When only simple capabilities are needed, string methods are preferred because they are easier to read and debug, no joke. So say we just have a string t for 2 dot replace, defining what we're replacing and what we're replacing it with as the first and second arguments respectively, and we'll get back the string with 2 replaced with 2. Mathematics. The math module gives access to the underlying C library functions for floating point math. And remember, if you didn't know, that by the default Python interpreter and everything is written in C, the C language. So if you import math, and you can use the .cosine method, and in passing those arguments to that, you're also using the math.py method. Divided by 4, and you'll get bada bing, bada boom. You can do logarithmic stuff with math.log. This would obviously be the number there that you wanted. The random module provides tools for making random selections. So random.choice with a list of strings passed in will just return a semi-random. It's not truly, in the pure mathematical sense, it's not truly random, but it's functionally random for human beings. It's good enough. Random.sample with a range and a number and an integer passed in, you will get 10 random samples out of the range 0 through 99 in this case, right? Random.random with nothing else passed in just literally just gives you a random float number. Random.randrange with one argument passed in will choose from a random integer chosen from the range passed in. The statistics module calculates basic statistical properties, the mean, median, variance, etc. of numeric data. So, you've imported statistics, and then you've got a data here, or a list here, set equal to just a bunch of floats. And you can pass that list in as an argument to the .mean method of statistics, and you will get the mean average. And I think from there, if you can't figure out what these two mean after that, I don't think anything that I can do could help you. The SciPy project, that's not true. This method will return the median average, and this method will return the variance, okay? Sorry, I was rude. The SciPy project has many other modules for numerical computations. Internet access. There are a number of modules for accessing the internet and processing internet protocols. Two of the simplest are urllib.request for retrieving data from URLs, and smtplib for sending mail. So in this example provided, after we have imported urlopen from urllib.request, with the output of passing in this URL as argument to urlopen set to the variable response, we can then iterate through the response for line in response, and each line we can use the .decode method to convert the bytes there into a string. We set that equal to this variable line, and then we can if line.startsWith, if we can use the startsWith method with a string passed in as argument, looks for that in each line. We can print that line in which this is found at the beginning, that line after having been passed through the rstrip method, which will take away the trailing new line shit. And so, using this URL and all of these interesting tools, we will get returned date, time, and with this long, very thorough, detailed date time from worldtimeapi.org. And if we use smtplib, set a variable server equal to the result of using smtp method from smtplib on localhost, then use the .sendMail method with this variable server with the arguments soothsayer at example.org and jcaesar at example.org, and the multi-line string saying to, from, beware the Ides of March, and then we can quit. Notice, note that the second example needs a mail server running on localhost. This wouldn't work if that didn't make it, if that wasn't there. Dates and times. The date-time module supplies classes for manipulating dates and times in both simple and complex ways. While date and time arithmetic is supported, the focus of the implementation is on efficient member extraction for output formatting and manipulation. The module also supports objects that are time zone aware. So, for instance, if we from datetime imported date, it will get set a variable equal to date.today, and if we call it after this, this is going to give us datetime.date 2003 12/2. Was this written in 2003? Damn. 20 years, folks. Isn't there an update for now? Find out for the tutorial. Damn. Alright, and if we use the strf time on now, we can specify exactly how we want it formatted using strings. And we want it this kind of month, day, year, this kind of day, B year, I guess the big written month, except it's abbreviated. You know, again, this is the sort of thing you look up. I mean, if you want specifically a specific kind of format and you can't remember which one it is, I mean, just look that up at the time. As long as you know that this exists, that the string function time, or format time. Dates support calendar arithmetic. So, birthday set equal to date with the year, month, and day passed in as 3 separate arguments. And if we update the value of the variable age to equal now minus birthday, and then we can calculate exactly how many days that constitutes. 14,368. All sorts of other neat tricks, I assume. Data compression. Common data archiving and compression formats are directly supported by modules including zlib, gzip, bz2, lisma, zip file, and tar file. Import zlib. We can set s equal to a string with b in front of it, sort of like an f string, and this would mean when you check the length of s, we get 41 because it's been compressed in some way, I assume. Not clear. T we can set t equal to zlib.compress with s passed in this variable, and check the length again, and we'll see 37 instead of 41. And then if we decompress it, we'll get the original back, which has which's wristwatch. And if we use the crc32 method of zlib, passing in that variable as an argument, we get a bunch of numbers. I don't know what the hell's going on there. Performance measurement. Some Python users develop a deep interest in knowing the relative performance of different approaches to the same problem. Python provides a measurement tool that answers those questions immediately. It is pretty neat. For example, it may be tempting to use the tuple packing and unpacking feature instead of the traditional approach to swapping arguments. The timeit module quickly demonstrates a modest performance advantage. So, this is you literally just timer and then as argument the thing that you're trying to do. Two different methods of assignment here, basically. Time it, and you will get back the actual time that it took the computer to do this. And here we see an improvement of 3/100ths, roughly, of a second, I guess? I'm not sure what unit of time is being measured there. In contrast to timeit's fine level of granularity, the profile and p-stats modules provide tools for identifying time-critical sections in larger blocks of code. Quality control. One approach for developing high-quality software is to write tests for each function as it is developed, and to run those tests frequently during the development process. Never wait until the end of any project. That's not just in programming. Measure twice, cut once. The doctest module provides a tool for scanning a module and validating tests embedded in a program's docstrings. Test construction is as simple as cutting and pasting a typical call along with its results into the docstring. This improves the documentation by providing the user with an example, and it allows the doctest module to make sure the code remains true to the documentation. Say we defined a function called average that has one parameter, values. Sorry, I thought somebody was tapping on my bedroom window, but it's just big hail. Okay, this improves the documentation by providing the user with an example, and it allows the doctest module to make sure the code remains true to the documentation. So say we define a function, average, which has one parameter, values. Here's our explanatory docstring, which says computes the arithmetic mean of a list of numbers. and then it gives an example of what the output would look like using it. That's helpful. And it will return the sum of what is passed in as values divided by the length of what is passed in as values. Then, if we import doctest, we can use .test.testMod, and it will automatically validate the embedded tests. Very interesting. The unit test module is not as effortless as the doctest module, but it allows a more comprehensive set of tests to be maintained in a separate file. So, using it with our test statistical functions class, we've defined that takes in unit test.testCase as its argument. And here's our function test average, which is not that function, but and here's a series of tests. And then after this, using unit test.main, we'll calling from the command line will invoke all those tests. Neat. Batteries included. Python has a batteries included philosophy. This is best seen through the sophisticated and robust capabilities of its larger packages. For example, the xmlrpc.client and xmlrpc.server modules make implementing remote procedure calls into an almost trivial task. Despite the module's names, no direct knowledge or handling of XML is needed. The email package is a library for managing email messages, including MIME and other RFC2A22-based message documents. Unlike SMTPlib and poplib, which actually send and receive messages, the email package has a complete toolset for building or decoding complex message structures, including attachments, and for implementing Internet encoding and header protocols. The JSON package provides robust support for parsing this popular data interchange format. The CSV module supports direct reading and writing of files in comma-separative value format, commonly supported by databases and spreadsheets. XML processing is supported by the xml.etree.elementtree, xml.dom, and xml.sax packages. Together, these modules and packages greatly simplify data interchange between Python applications and other tools. The SQLite 3 module, SQLite 3 module, is a wrapper for the SQLite database library, providing a persistent database that can be updated and accessed using slightly non-standard SQL syntax. Internationalization is supported by a number of modules including getText, locale, and the codex package. Boom! You read through the whole Python tutorial and the official documentation. Thank you very much. Well done. You're making the world a better place by making yourself more literate.